Any ideas? Yeah. Just two parallel sides?
Well, I didn't want to say like, I'll say like two, I'll say two pairs.
All right, I like that.
And I want to say four because that's because they all.
I like what you said, with two pairs of parallel sides. Okay? So what that means is, okay, in our picture, okay, this side is parallel to this side, and then the top side is parallel to the bottom side. And notice that we designate them with a different set of arrows. Okay? All right, so that's going to be one of our properties, is that the opposite sides in a parallelogram are parallel. That's one of our properties. It's a very, basic one. It's in the title of the word. Okay? All right. When later on, when you see like, like how we write triangle ABC, they're gonna do a symbol like this. So just so you're aware of it, parallelogram ABCD. Okay, so they're gonna abbreviate parallelogram with just a picture of it. Okay. Reminders too, when you do your labeling, okay, you always go in a circle. Doesn't matter which circle you go in, you can go clockwise, counterclockwise. So A, B, C, D. Okay, so if you ever have to draw a picture, make sure that you're not going like diagonally, A across to B and then like making a Z or anything like that. You gotta go in a circle, okay? All right, does anybody know two properties that deal with opposites in a parallelogram? And it gives you congruent. What do you think are congruent?
Angles.
Okay, so the opposite angles are going to be congruent. That is correct. All right, and the opposite sides. Okay, so that means in our picture over here, the opposite sides are congruent. So tick, tick, double tick, double tick. Okay, and then I'm going to mark in our parallelogram here. Angle A is congruent to angle C, and angle B is congruent to angle D. Okay, so our opposite sides are congruent, our opposite angles are congruent. All right, so the goal is to use it. So in example 1, can we solve for x? What does x equal? X does not equal 12. 8, because x plus 4 equals 12, x equals 8. So, understand that the opposite sides are equal to each other, set them equal to each other. What does y equal? Easy one. Y equals 65. Okay? All right, example 2. Try it on your own. Tell me what you get. Don't forget literacy skills. Ways to solve this. Anybody got an idea? I like your way if you want to volunteer. Andrew, you want to volunteer? Okay.
Since like the line is 180, you just put the 10x minus 2 plus 6x plus 6 equals 180.
Okay.
You can do something at the top.
All right. So he remembers from chapter 3, since these two are parallel, your consecutive interior angles add up to 180. So he did 10x minus 2 plus 6x plus 6 equals 180. And notice that he only has an x value in which to solve for it. That's one way that you could have done it. Okay? Did you get an x value for this? So he got x is equal to 11. And then he's going to do the exact same thing for the y, and he's going to say that 6y plus 11y minus 24 also equals 180. And did you get a y value of 12? Okay, now that's one way to do it. And the benefit to doing it that way is that you only have one variable in each equation and you could solve for it. I saw a number of other people doing the following. They were taking the opposite angles and setting equal to each other. So 6y equals 6x plus 6. And some people were dividing by 6 and getting y equal to x plus 1. And then they were taking and doing the same thing with the other one. 10x minus 2 equals 11y minus 24. You can do that. All you got to do is take whatever y is and plug it back in, okay, with your x plus 1, and then solve. You should still get x equal to 11. So both ways work, okay? But have we answered the question yet? No, what'd the question ask? Okay, so what's the measure of angle A? 108, okay? And the reason is it is 10 times 11 minus 2, or 108. And what's the measure of angle B? You should get 72, either 6 times 12 or 180 minus 108. Either one works, okay? Questions on that one? That one was a tricky one, okay? But it also leads us to another property, okay, that Andrew used, okay? In a parallelogram, the consecutive angles are supplementary. So he used this idea in order to solve for the missing angles, okay? So showed you how you could have done the supplementary angles, showed you how you could have done opposite angles are equal to each other, okay? So that's property basically number 4 that we've done, okay? Parallel sides, opposite sides congruent, opposite angles congruent, okay? Consecutive angles are supplementary. And so now number 5th one, diagonals. Remember we talked about what a diagonal is back when we did the discovery exercise for polygons, okay? In a parallelogram, the diagonals bisect each other. Okay, so if you need a picture to go with this, okay, I've got this diagonal and I've got this diagonal, and it's bisected, so the 2 red parts are congruent to each other, and then the 2 blue parts are congruent to each other, okay? Not all 4 are congruent to each other, all right? So 2 are equal to each other, 2 are equal to each other, all right? Now what that means is, one of the things that we're going to learn later on in the chapter is that the point of intersection for the 2 diagonals, so in this example P is the midpoint of each diagonal. So P is the midpoint of LN, P is the midpoint of OM, okay? So can you find the coordinates of P? See if you can do example 3. You got C? Okay, so he says point P is across 2 and up 3.5. He said C? Oh, C. So, I apologize, okay. So he said across 2.5, up 2. Everybody okay with that? Because across 2.5, up 2 would be this point to the left of P. So what should it be? It should be A, okay? All right, so we're going across 3.5 and then up 2, okay? Reminder with our midpoint formula, okay? You just are basically adding your x's together, dividing by 2, adding your y's together, and dividing by 2. So if I took, say, O and M over here is at, what, 3, 4, 5, 6, 7, 7, comma 4. So 7 plus 0 divided by 2 is 7/2. 4 plus 0 divided by 2 is 2. So just showing you that it works using the midpoint formula, okay? All right, so in example 4, the measure of one interior angle of a parallelogram is 0.25 times the measure of another. What's the measure of all the angles? Okay, so I'm gonna start out by drawing a parallelogram. Always do that, okay? If you want to label, feel free to label. A, B, C, D. Okay? The measure of one of them is 0.25 times the measure of another. Ideas? What are we going to label the other? If they don't tell you what it is, what do you label it as? X. So we've got, this is X and this is X. So now the other angle is 0.25 times it. What does that mean? 0.25x. And if A is 0.25x, what's C? 0.25x. Okay? How are we going to solve for x? What's one of the properties that we learned about a quadrilateral? The sum is 360. Create an equation, set equal to 360, solve for x. Go, see what you get. All right, so I think you got 2.5, x is equal to 360, x is equal to 144, and a lot of people stopped there. What's wrong with that? It says to solve the measure of each angle. So right now, you know that angle B and angle D equal 144. What's the measure of angle A and what's the measure of angle C? 36, because you got to take 0.25 times 144. Okay? And remember, that's that literacy skills that we keep talking about. Like, for example, on the homework the other night, we had that exterior angles, and people were setting equal to interior angles. Okay? All right, in example 5, you got to solve for x and y. It does say explain your reasoning here. So you got to be thinking about, you know, why you're doing what you're doing. Okay? So, for example, let's start with x. Any answers for x?
20.
X is equal to 20. Explain.
Because TS is like TS, it's the same. They basically share a side.
Okay.
Side length.
Okay? As in, if QR is 20, TS is the opposite side, so it's 20. And then UV is opposite of TS,
So therefore it's 20.
therefore it's 20. Very good. Okay? That's kind of like the transitive property. If A equals B, B equals C, then A equals C. Okay? What about Y? Yeah?
I might be wrong here, 40.
Okay? He might be wrong. He's not sure. Anybody got an idea? Katie?
Oh. Because like the top would be like where U is would be 80.
The top,
It's like flipped around.
the top where U is. Well, there's 3 angles at U, so
I know, so like.
Is it 60? Is it 60?
is it 60? So why is it 60?
Yeah.
Because I did 80 plus 40 because the triangle has to equal 180.
Yeah.
Okay?
And then I got 120.
Okay. What triangle are you talking about?
Well, first because I flipped it around to make it like even with it, so the angle V would equal 40. So because they're the same triangle, it's just flipped.
Okay?
So 80 would equal U.
So I think this is what you were talking about, Katie. The one up here is 80?
And then so 80 plus 40 equals 120.
Okay.
And then 180 minus 120 equals 60.
I like it. Okay? And remember, the reason why this is 80 is because of if this line is parallel to this line, here's your Z. You've got alternate interior angles. Okay? And then T and V are congruent to each other because opposite angles in a parallelogram are congruent to each other. Okay? And so we just put all those pieces together, and therefore Y ends up equaling 60. Okay? Questions there? All right, so then over here, okay, it's just more the same. I think maybe what we'll do is Oh, you know what, let's go down to number 8, because there is like one or two like this on the homework, and then we'll go back to the quadrilateral tree, okay? All right, see if you can find all the different angle measures that are listed, okay? It's similar to the concept that you just had to use in order to solve for y. Just talk about strategy here, okay? So a couple things. You could easily start with the one at E being 117 because vertical angles. The one down here, 80 alternate interior angles. Down here at the D, this is 23. Again, you know, your alternate interior angle concept. So start with basic things. And then after that, it looks like it's going to come down to the sum of the interior angles adding up to 180. So what's this angle next to the 80? 40, which means that this one up at the top is 40. Okay? All right, so then we should be able to do 180 minus 117 and get 63 and 63. So what are the angle measures next to the 23s? What'd you get? 37, and then alternate interior angles 37. So notice a lot of the angle measures end up being the same because of alternate interior angles, vertical angles, etc. Okay? So in some of the cases, it just comes down to adding them together. The first one, AEB, we just knew from vertical angles. Who's got AED? AED is 63. BAD? Okay, it's 120, because the 40 and the 80 put together. ADC? You got 60, because of the 37 and the 23 added together. BAE? 40. ECB? 80. DCE? 40. And DCB? 120, because you add the 40 and the 80 together. Okay? A couple people were asking about, you know, how do you know which angles? Remember, you're always looking at the vertex as the middle letter. Okay, so just remember, like if I'm doing AEB, I go from A to E to B. E is the vertex. That's the angle that I want. Okay? So just reminders on there.